Let me continue on. This is chapter 6, part 6 of the video series with it. And I'm going to talk to you about moving beyond this right now, is that we have value and reference parameter in the memory allocation. So when a function is called, memory from the formal parameter and its location variable is allocated in the function of the data area with this. What does this mean? When you call a function, you're passing along as the actual parameter inside of that function in the main. However, when you actually make a copy of that function variable, that reference variable that you have in the main with this, the variable allocation is just only a copy of that function area with it. That's what it's talking about. For value parameter, the actual parameter is copied into the formal parameter of the memory cell. This takes up a lot of memory. You can see what I did with that file that I copied from that picture. I copied it from that directory, copied it into the desktop. Both files exist in both places. Changes to the formal parameter do not affect the actual parameter. So if I went in, I changed this formal parameter, this does not change anything to the actual parameter with it. Okay, so a few things to keep in mind as we go through this thing. This is becoming a little bit more important than the stuff that we will get into with, as you can see. Value and reference parameter and memory allocation continues with this thing. So for a reference parameter, the actual parameter address is passed through the formal parameter. Okay, so when you call that function, you're actually calling the actual parameter, and that actual parameter is passing through the formal parameter to get to the function's parameter, the function at the bottom of the parameter. For instance, let me give you for instance what this means. In this function that I just called right here, all right, this function. Let's say this is a reference parameter, and I went back. This is example 6-11, and I went back and I put an ampersand right here. Okay, after this data type right here. So this makes it a what? A reference parameter. Agree? This makes this a reference variable, to be exact, right? This is our new reference variable. So if I call this thing now, what's going to happen is that if I call this function number, I pass in my number in this thing, right? In this case, I pass in number as, let's say I pass in number as 5. Okay? So what is this doing? When I call this function, this is, what type of parameter is this right here? This right here is now an actual parameter, and I'm using the memory address of the num, which is the formal parameter, and it's going to access what? This number, change this number, remove this number, whatever the output's going to be with it. So I have modified, if I really want to modify and change this thing after I do this thing. Okay, so if I do this number right here would be 5. Okay, so it's going to change it after if I did this way. However, like I said, we're going to do another example of what I just said in a second here. So let me just put that back right here. Okay, so let's go back to the slide right here. Both formal and actual parameter refers to the same memory location. The same memory location. During execution, changes made from the formal parameter value permanently changes the actual parameter. So when you are changing the formal parameter value, you notice how I can actually change the actual parameter value with that. Correct? So as you can see, this is really powerful tool that you can actually use. Let me continue on. Also, you can use reference parameter in a value returning function. Not recommended. Not recommended. So the question is, can you have a void function and have a value returning? And the answer is it's not recommended. Okay, because we want to keep value returning function that has the word return, which is a copy, separate from what is a reference variable. By definition, a value returning function returns a single value. Remember now, because the void returning function, you can return more than one, right? If a function needs to return more than one, change it to a void function and use a reference parameter to return the value. Okay? So if you have more than one, you could actually use it as a reference parameter to change it to it. Okay? These are so important concepts. I hope you take the time to read, because a lot of this stuff is really abstract, and I understand that you reading this stuff the first time you might not get it, might not pass across, understand what's going on with this thing. But I hope you do take the time to read this stuff. After this stuff, everything goes downhill with it. It's really easy. Scope, if you define the scope of a particular variable or identifiers. What are identifiers? They're constants, function names, and variables. It resides inside of that curly bracket. So if you define something that is outside of, let's say you define a variable in here. If I did one in here and I did, for example, int x, okay, this x can only exist in between these curly brackets. When I'm in my int main, I cannot access that. So a scope can only hone in, allow you to use this only. Now, there are instances that between your outside of your int main and your void, this place right here, between your using namespace, you've done this before, is when you declare some variables and constants. That makes it what's called global. Okay, so global means that every function outside of my int main, I can access that. And the scope, if I have this particular number in here, a number can only be used inside of int main. Func value parameter cannot access number in here. Does that make sense? So that's what it means by scope with this thing. Let me come down and again read through this local identifiers, global identifiers. There's everything what I just said about it. With it. So I would like to look at some examples, and I don't want to take any more time reading slides to you with this thing, but if you could for me, please take the time and read chapter 6 with it. The next part I want to talk to you about is the static and automatic variables with this thing. This is a really good definition is the automatic variables that you have is memory is allocated at the block entry and deallocated when the block is exit. So when you actually declare a variable, what I did a few minutes ago, this is an automatic variable that I can actually declare, and once that block exit, that memory just goes away. However, a static variable, memory remains allocated as long as the program is executed. So what does that mean? Global variables declare outside of any of the blocks are static variables with it. So if you declared something outside of this thing right now, if I place this outside in the global area, that memory is still holding up, taking up memory. But if you put a declaration in here inside this function or inside of this function like this, when this function is being compiled, it's taking up memory when it's being run. Same thing if you call something in a local here. If you're using this function is being run at the same time with it as well. Let me stop.